Okay. So what do you think about life mathematics, both of you?
Mathematics in daily life.
Mathematics in daily life. Good. So what have you ever done with mathematics in daily life?
Mark calculation.
Mark calculation. Okay.
After getting exam sheets, ma'am.
Right. So what you will be doing there?
Ma'am, I'll be adding everything.
So addition, subtraction. Anything else we are employing other than this addition, subtraction, multiplication, or division, which are basic maths, right? So anything other than that that we are using in daily life?
Fractions, ma'am.
Fractions. Where?
Like when we cut a cake and all that.
Oh, right. Okay, that's a good example. Oh, in that time, we are using fractions. Then, Skanda, what about you? Do you use math in your life?
Ma'am, just a second, ma'am.
Okay. Skanda, what happened?
Yes, ma'am.
Yeah. Can you hear me?
Yes, ma'am.
Okay. Did you understand the question?
No, ma'am.
No. What was the question? Can you say it?
Which type of math we use in life, ma'am? Daily life.
Yeah. So daily life, what kind of maths you're employing it? Like that, right?
Yes,
Okay, so do you know anything with that?
And money, ma'am.
Nothing. Okay, right. So let me give an example for you. Maybe you can find that you're even using maths. Yeah?
And money, ma'am.
Money. What are you doing with money?
The banks, they will manage the money, ma'am.
Where is the maths involved in it? It is money management, right?
Yes, ma'am.
Then where is the mathematics?
I'm counting, ma'am.
Counting. Okay, right. That can be done. Then have you seen yourself and your brother? Okay, who is the bigger, who is the smaller?
Yes, ma'am.
Who's the bigger?
I'm brother, ma'am.
Your brother is bigger, right?
Yes.
So when you see your brother and you can see something in between you and your brother. So that you're saying that you're shorter than your brother, right? So those things also math employment. So we'll be saying this, right? Let me share this. Okay. So we will be seeing that. Right. So we will be seeing that some number is bigger. 10 is bigger than 9 or 8 is bigger than.
Comparison, ma'am.
Yeah, we are comparing them. Okay, we are.
Ma'am, when we buy stuff, like when we buy things also we'll be using.
When we buy things. Okay.
Like cost.
Cost. Right. So in selling and buying.
Maybe me needing balance or change or something like that.
Yeah, we'll be calculating it, right? So how many we have bought, okay, how many the prices we'll be adding, and how, what amount you have given to them. So from that you'll be subtracting, then the rest amount you'll be knowing that it should be coming to you. If he is not going to give, means you will be asking them, okay, why you are not giving the money, right? So this is all some kind of life mathematics, okay, which are mostly whatever you have said is just with the addition, multiplication, subtraction, division. So with this only you have said. So, but there are more things to it. The mathematics.
Ma'am, I told fractions.
Yeah, fractions. Fractions also kind of division. Yeah.
It's kind of like ratio.
Yeah, it's kind of like ratios or it's kind of division, right? Okay. So yeah, we'll be seeing more of it. Now this ratio, we just started it now. Okay. So there are ratios, proportions and variation. And in the previous class itself, I told you something, right? Percentage about. So we'll be elaborately seeing that percentage also in this class. Okay, if we are finishing ratios means we'll be going to the percentage. Okay, so now getting into this ratio. What is exactly ratio? Okay, so it is nothing but fractions, how we are dividing them. Okay, or what we can tell it as when you compare two quantities. Okay, so fraction can be done with what to say, yeah, even fraction you will be doing it with two quantities, right? So within two quantities, how you are going to separate it. So that is what fraction or ratio or division. Okay, so see this over here. The ratio is nothing but it shows the relation between, okay, a relation between two quantities. Okay, or to compare two quantities. How we are doing, you're comparing two quantities. So how to say, if there are 10 oranges with you and you are having 15 apples also with you, now you are going to compare the fruits. Okay, with you, how many fruits are there? 10 oranges and 15 apples. So these you are going to compare them. Okay, so when you compare the counts of these both, you'll be getting it, you'll be getting some value. Okay, how to say that? See this, some 10 oranges and some 15 apples. Okay, let's say 10 oranges and 15 apples. Now you need to have the minimal number of them. Okay, now we are going to compare them. How we'll be establishing this comparison? Either by putting them into a division, like this 10 by 15. So you are establishing a relation right here. See, if I write them as 10 and 15 means I can't establish anything between them because they are separate individual numbers. Okay, but if I produce something like this, okay, here and I can compare. Okay, so now what I'll be doing, okay,
Ma'am, morals we can use ratio symbol, ma'am.
yeah, or else we can use ratio symbol also. Okay, so that is a symbol for ratio. Or else so if I am writing this means I can write it like this also, this will also mean the same. But now what it does for us, this kind of ratios, okay, it will bring us to the least possible number between, or least possible way that you
Simplest
can
form,
compare.
ma'am.
Yeah, the simplest form. Yeah.
Ma'am, can you hear me, ma'am?
Yes. Yes, Kanda. Skanda, can you hear me?
Ma'am, I can't hear you.
You can't hear me. Now?
Ma'am, he left.
Yeah.
Ma'am, so if we write like 10 by 50, we can write 2 by 3, ma'am.
Yeah, we can write 2 by 3. Skanda, can you hear us now?
Ma'am, now I can hear you, ma'am. From next itself, your voice was breaking for me, ma'am.
Okay, right.
It's like lagging, ma'am.
Okay, right. So we were talking about these ratios now. See this?
Yes.
The ratios are nothing but a relation you're establishing, okay, between two quantities. Like
Yes.
how we started with a relation between an apple and an orange and the counts of them. Okay, there are 10 oranges and 15 apples. If we are starting with that means, okay, when we are establishing, we want to establish a relation between them, some kind of relation between them. We'll be letting them in a fractional manner or a ratio. Okay, ratio will be involving this symbol. Okay,
Yes.
which we call is to. Okay, is to is the name. Okay, 10 is to 15. Okay, like that. But when you employ this kind of relation, okay, you'll get the simplest form of those two values. Okay, how can we say that? See, I can establish this as this also, that in division also I can say my ratios. I can put my ratios in division form also. Now see, when it is in division, what will be the values then? Now, if you put 10 by 15, what will be the value for you?
10 divided by 15, ma'am.
Yeah.
1 minute, ma'am. Ma'am, or else we can like cut it off, ma'am, with 5.
You can cut it off with 5.
We can cut, ma'am. We can cut it off with 5, and we'll get 2 by 3.
Yeah. Okay. Okay. You're saying, okay. It's kind of what I meant also. It's the same, 10 by 15 means, okay, how you can cancel, how you can reduce them into the simplest form. Okay. It does not need to be converted into decimal values. See, this is a smaller value. This is a bigger value. So when such a thing is happening, we'll be always getting the answer in decimals, because this is small, this is big. Okay, so we can to make a simplest form, we can just cut them, okay, in a common HCF. Okay, the common HCF, what it is, it can be having, okay, that we can divide on both the sides. So the common means what? See, they both are coming in 5 tables, right? 5 twos are 10 and 5 threes are 15. So this will be its simplest form. That means, see this, I can
Understand,
right. See this, 10 by 15. Okay, 10 by 15 is there. And I am going to write it in some form like 5 into 2 divided by 5 into 3. I can write this as this, right?
Yes, ma'am.
So now see, 5 and 5 are there. I can cancel them, right? Because they are same number on the top and bottom.
Yes.
So now see, what is the number left? 2 and 3. Right?
Yes,
2 by 3. So now see that I'll be having this 2 oranges for every 3 apples. Okay, can you understand this? There are 10 oranges and 15 apples in it. And I am established a relationship in between them. And I have come to the conclusion that for every 2 oranges, there are 3 apples with me. Right? So this is the simplest form to mention your ratio. Okay. So now if I'm saying that, okay, Shivani can have 2 oranges for every 3 apples. Okay. And she can have any number of oranges and any number of apples. Okay. But it will be in the ratio of this only. That for 2 oranges, 3 apples will be there. Okay. So if you multiply it.
So this is kind of like data handling, ma'am.
Data.
Like when we write a lot, we'll be writing like 1 car equal to 100 cars, kind of like that.
No, not like that. Not like that, but no. How we are saying the ratios means we are just comparing the values, okay, and we are establishing a relation in the simplest form. See this, if I write some numbers like 75 and 87. Okay, if I need to establish something means there are counts. See how many counts are there? 75 and 87. A big number, right? So if possible, I can reduce them means I'm doing that. So that is the relation. I just need a relation between them. Okay, but I don't need any kind of value for it. Can you get it? Just the relation between them. Okay, I need to know the relation. If I say with my friend, what is my relation? Okay, but I won't be saying that how aged we are. Okay, maybe we are 50, but we are as thick friends as 20 years old. Okay, so that is the way we are mentioning the relation. but whatever the other parameters are or other values are, okay, we are not considering the values but the relation between them. So to find the relation, the simplest form is enough. Okay, so can you get it now, Skanda? Skanda? Skanda, can you hear me? Can you hear me?
I can hear you, ma'am.
Okay, did you understand?
Only I can hear you, ma'am.
Now only you can hear me.
Yes, ma'am.
You should have told me, right, when I got stuck or when I stopped before itself. If my voice is off means unmute and tell me, okay? Then only, you can understand everything. So I can pause for some time for you to get the network, right?
Yes, ma'am.
Okay. Did you get this, what we discussed so far?
Ma'am, yes, ma'am. 2 by 3 I got, ma'am.
2 by 3 you got. So what is 2 by 3 now? Why we have done this? 10 is to 15 to 2 by 3. Why we did it?
And to convert into fraction, ma'am.
To convert into fraction. Then what is the meaning inside it? I just told that. You didn't hear it?
Oh, ma'am.
No, then you have to tell in between.
Yes, ma'am.
Okay, if you're not hearing means you have to tell.
Yes, ma'am.
Okay. See this, why we have done this means, see what we have said, it shows the relation between, right? It shows the relation between. Relationship means, okay, with that number, let's say this is going to be A number, this is going to be B number. Okay, how this A is related to B. This is what we are going to establish here. Okay, and whatever this A value can be, whatever this B value can be, we won't be minding it. Just the relation between them is what we are going to find. To put it in simple forms, I'm saying that, compare you with your brother. Okay, you and your brother, in the simplest form, let's say, what is your age, Skanda?
Now 11, ma'am.
Come again?
I'm 11.
11. What is your brother's age?
I think 16, ma'am.
Your brother's age is 16.
Yes,
He's
ma'am.
studying 10th now?
Yes, ma'am.
Okay, so 16. So see this, 11 and 16. Okay, let me put your value as, for an easier convenience. I'll put your age as 12. Okay, so 12 is to 16 is your age with your brother's age. So now what we need to find, I need to find the relation between you. What is the relation? Can you guess it? What could be the relation between you?
Ma'am, 6 by 8.
No, not that one I am asking. Okay, just the simple manner. What is the relation between Skanda and his brother? By seeing these numbers, what we can tell from it? See, this number is small and this number is big, right?
Yes, decimals, ma'am.
Come again?
If we divide, we'll get decimal, ma'am.
Yeah, if we divide, we'll get decimals. But see this, that Skanda's age is lesser than his brother's age. So this is the relation now. See this? This number is somewhat smaller than this number in some way. Okay. And that, what is that way? That is the relation now. Okay. And that is what you need to retain or you need to keep.
Retain means, ma'am?
Retain means you need to keep it. Okay. Retaining means keeping or yeah, keeping it. Okay. So now 12 is to 16 is there, right? Now these numbers are bigger, right? Okay. See, after 4 years or 5 years, this numbers will be changing.
Yes,
Okay.
ma'am.
Or if we go past in backwards, this number will be changing then also, right? But say me that between the age difference between you and your brother, will that be changing?
No, ma'am.
No, right? And that is the relation there. Okay. The values can be changing. Okay. But the relation won't be changing. Okay. So now to know that relation exactly for every time, because see this is a bigger value and this is a changing value. Okay. But we need to know the difference or the relation between them. What we should be doing here, we need to reduce into the simplest form now. Okay. So now now if we reduce it to simplest form, what we are going to do is we can write it as
6/8, ma'am.
6 by 8. That's all.
Ma'am, but
reduce
we can divide it further, ma'am.
Yeah, what is the simplest form?
3/4, ma'am.
3 by 4, right? So this is the relation between them. Okay, or 3:4. So if Skanda's age is 3 times some number, means his brother's age will be 4 times that number. Can you understand this? If Skanda's
Yes.
age is in 3 multiples, means his brother's age will be, if that relation is maintaining, means it will be 4 multiples. Okay. So this is the relation between Skanda and his brother. Okay. And the simplest form is this, that is they are between 3:4 ratio. Okay. But this can be changing. Okay. So this is the ratio for now. Okay. Let us see this example also. Okay. So you are clear with this, right? With this example that we discussed.
Yes, ma'am.
Okay. So now we'll see which the example that I've given here. You can take a note of this one. Okay. The one which I put in the box.
Ma'am, I wrote the other one, ma'am, that 10/15.
Okay. The 10 by 15 is also fine. Okay. Shall I rub this? Skanda, you're noting? You're noting?
Yes, ma'am.
Okay. Take it complete and tell.
Yes, ma'am.
Completed?
1 minute, ma'am.
Completed or not?
1 minute, ma'am.
Okay. 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 Right.
Completed, ma'am.
Right. Okay. I'm just rubbing this. This will confuse you. Okay. So now we'll see this example over here. What they have said. If there are 20 men and 40 women in a company, okay, then the ratio of the number of men to the number of women is 20:40. Okay. When you just starting the relationship, means you'll just write the values as such. Okay. That is 20:40. 20 men and 40 women. Okay. So now what we are going to do is, okay, for one man or for one woman, how many men are going to be there? Okay. Or in some ratio kind of that we are going to find. Okay. So now what we can do, by using fraction, it can be written as 20/40.
Ma'am, we can use like 2 tables or 20.
Yeah, we can use 2 tables or we can use 20 table itself, right?
Yes, ma'am. 20 table we can use.
20 table, right? So 20 table means it is
20
1 by
4, ma'am.
yeah,
40.
20 into 2, 40. So it is 1/2, right? So now our ratio is what? 1/2 means I can write it as 1:2. Okay. So this shows that the number of men is half the number of women in the company. Right? See, the number of men is half the number of women in company. Or we can say that for every man, there are two women. For every man, there are two women. Okay. Or it can be written as 1:2. It will be reading as 1:2. Okay, clear? Skanda,
Yes, ma'am.
clear for you?
Yes, ma'am.
Okay, right. So we can move. Okay. So see this over here. We can write A by B as A is to B, A to B. Okay. Or 4/5 as X is to 7 as 3 to 5. So like this we can write. Okay, that A is for B. It has some relationship. Like I said before, for one woman, there are for one man, there are two women, right? So for A, that is one, there are two, that is B. So A to B, okay? So this is the manner we are seeing this. Okay, we are moving now. Now we'll just see some other examples also to this for getting this in a clear way. Okay, how these ratios are working. Okay, in our daily life, we generally compare two things like comparing height of two persons, speed of two trains, etc. Won't we do this? As now I said, na, comparing Skanda's height with his brother, or we'll be comparing two trains distance,
Ma'am, we
train
will
speed.
be like who can do it faster or ma'am.
Yeah, that kind of things we'll be doing every time. We'll be doing, or what we'll be doing in market. If we go, means which fruit is good, is this tomato is good, no, it is better than the other one, we'll be checking that, right? So those kind of comparisons we'll be doing everywhere. Okay, so we come across terms like percentage ratio, etc. Okay, so now the example here given is Hina is 150 centimeter and Amir is 75 centimeters. And this is not true actually. See, 150 centimeter and 75 centimeter. Can this be happening?
No,
No,
ma'am.
right? No, no, we can't be of 150 and 75 centimeters, right? So, but we could be when we are in babies like that. When we are in hands, then only we'll be in that size. Okay, so now take this as Hina is some 150 centimeters and Amir is some 75 centimeters. Now we find that Hina is 2 times taller than Amir, or Amir height is 1/2. How they have said this? See this over here. If we double this, okay, 1 minute kids. Sanjay, Sanjay, you have to join in the other link.
Okay.
Yeah. Okay. So now see this by, this is the height ratios, or this is the heights that are given for these two kids. Okay. By seeing itself, we can say that Hina is twice the size of Amir, right? But if we establish in a mathematical form, we'll be getting the same. That we write the ratio of
75, 1 times 75 and 2 times 1.
150, right? So we can write it as 2:1. Okay, that is Hina is twice the size of Amir.
Ma'am,
Okay,
we can't write 1:2, ma'am.
yeah, we can't write 1:2.
Why, ma'am?
Why? See, 1:2 means this is in this. Yeah, that is a good question. Okay, see, when the ratios are coming, we should not change its position. Okay, because if we change the position, then the ratios changes. See, when we return the Skanda and Srihari's heights, that is 12:16. Okay, the ages, right? So 12:16. If I write what was the ratio of them? The final ratio? 12 to 16 is?
3/4, ma'am.
3/4 or 3:4, right? So see now, if I change, if I write instead of 3:4, if I write 2:4, what would be happening? Sorry, 4:3, what would be happening? 1 minute.
Hello.
Ma'am, I think you have joined in the other link.
Okay. This is 948, right, ma'am?
Yes, ma'am. You have to join in 971.
Okay. Sorry.
Right. So now see this. If I change Skanda's and Srihari's age ratios, now what would happen? That instead of writing 3:4, if I write 4:3, then what would happen? The ages are changing, right? That
Skandas will be like multiplied by 4.
yeah, then Skanda will become the big brother there. But it is not true in reality, right? So we can't do that. That's why we can't write it like that. See, 150 is how many times? 75. If I write 1 means 150 is going to be 2, right? Okay, so this is how we should be writing. You should not change this. Okay, now what? Yeah, see, this is also one important point of view. Okay, for comparing two quantities, the units must be same. Okay, when you compare two quantities, the units must be same. So you can't compare, okay, you can't compare an age and a height together because they are not in the same plane, you can say. Okay, they are not in the same line.
Ma'am, so like if it is given like one number is kilometer, another one is meter, we cannot compare, no?
No, that we can compare because kilometer and meters are what? Length only, right?
Ma'am, so when it is only like different units like kilometer and kg, ma'am.
Yes. Okay. Skanda, you got it?
No, ma'am.
No. See, this what Shivani said is, okay, if some unit is there, units are what? We'll be writing it as meters, kilograms, seconds, they are units, right?
Yes, ma'am.
So she's saying that if meter is there for one quantity and kilometer is there for another quantity. So she's saying whether can't we compare it? Okay. So can she compare it or not? This is in meter and this is in kilometer. Can she?
Yes, ma'am.
She can compare. How we are telling? Because this is in meter, but this is in kilometer. How she can compare? Just now I told you, right? The units must be the same for both the quantities.
Ma'am, if we can we can convert it and compare.
Yeah. Okay. So you can't just simply compare it with meters and kilometers.
But
There is
we
a
cannot compare km and kg.
yeah. Okay. So see this, if meters and kilometers are there, even this kind of simple changes, because see, meter also a length, kilometer also a length, right? So both are length, the same quantities, but even then they differ in the 10 raised to something, right? Meters and kilometers will be varying in that. So we need to convert it into either this into meter or this into kilometer and make them as the same unit and compare them. Okay. And you can't ever compare meter with kilogram. So this can't be done. This can't be done. Okay. But you can do this alone. This alone. Okay, Skanda? Can you understand this? Okay, it is simply put. Now, simply put, how we can tell? Like, okay. So if you are going to eat in a restaurant, okay, and you're going to eat some 2 plates of some kind of momos or something, okay, you're going to eat 2 plates of momos, but your mother or father can eat 4 or 5 plates, okay. So now you can compare yourself with your father and mother in the ability of eating, right? But you can't compare them, okay, with your eating, okay, with, after eating how long you can go and walk, okay. So with that you can't compare, because those are different entities, okay. So you need to calculate the energy and all, how it went, how much calorie it had produced. So with how much calorie you can walk, see, a lot of things are involved in it to compare them, to establish some relationship. So we can't compare them, okay. So it's simply a relationship you are establishing when you do ratios and you compare it, okay. And you should be having the same units. You should not change the position of your ratios, okay. So these things you should be doing. Clear now with ratios? Shall we do some problems? Skanda, what about you?
Yes, ma'am.
Okay, we'll see some problems. Maybe you will be clear with that, okay. Now, okay, so we'll see some problems first. Okay, so now they are saying that, okay, where's the question? Yeah, problem is, are the ratios 2:5 or 4:7 equivalent? Okay, so now what we are saying is, okay, the one more thing is, if 2 ratios are there means, okay, if 2 ratios are there means, you can compare those 2 ratios also. Okay, see this, we can compare different ratios and find whether they are equivalent or not. That how they are saying this, why we should be doing this equivalent thing first in case. See this, if I write 2:4 or 1:2, are they both same or not? Are they different? Are they same?
Ma'am, they are equal only, ma'am.
Yeah.
In 2 table, we can take like 1 and 4.
Right. Skanda, can you get it? Why I have done this?
No, ma'am. If we simplify 2 and 4 in 2 table, we'll get 1/2. That's it.
Yeah. See this? If I write 1:2 and 2:4, I'm asking that are they equal? I'm putting an equal symbol. Okay. See, I'm so whenever by just seeing this, we can't be knowing that. Okay. So what we should be doing, we should be converting your ratios into fractions. So now see, 2/4 is equal to 1/2. Can this be happening? Skanda, now say, can this be happening?
Ma'am, I can't understand, ma'am.
You can't understand. Okay. What part you are not understanding?
The first one, ma'am.
Tell again.
First one you don't know, ma'am.
Your voice is breaking, Skanda.
And now you can hear me, ma'am.
Yeah, now I can hear you. Okay, now I can't. Skanda?
Ma'am?
Yeah, now tell me.
And the first one you put no, ma'am.
Once again, tell me.
The first number you put no, ma'am.
Yeah,
That one only, ma'am.
this 2:4 is equal to 1:2. This one you can't understand.
And no, ma'am, the equal ratios, ma'am.
The before slides. These.
And no, ma'am. I think he cannot understand simplification. How to simplify that one, maybe.
Skanda, you can't understand that if I write 2:4, how this can be written like this, or this can be written like this. Which one you are not understanding? The first one or the second one?
Second one, ma'am.
The second one. Okay, see, if I write 2/4, see, 2 and 4 can come in what tables?
Tables, ma'am.
2 tables, right? See, 2 into 1 divided by 2 into 2, I can put, right?
Yes, ma'am.
Now see, on the top and the bottom, there are 2 and 2.
Yes, ma'am.
So I can cancel them, right? When they are in multiplication and division, I can cancel them, right?
Yes, ma'am.
Now what remains here? 1/2. So now they can be equal now. Now see, 2/4 is equal to 1/2.
Yes, ma'am.
Okay. So I can write 2:4 is equal to 1:2,
Yes, ma'am.
right? So if I say some other value, like 75:87 is equal to 25:29. Can this be equal? Now this is a big number, right? So you will be finding it tougher, but you can find it. Just think with this number, whether they can be equal or not. They can't be equal. Who raises for can't be equal? Shivani raises. What about you, Skanda? You're also raising your hand. But I say it is equal. How it can happen? Let's see. Okay. See this. If I multiply these two values, okay, into 2, into 3 into 3. Now this will become equal. See, 75 divided by 87 can be equal to 25 divided by 29. I am saying, right? So when you want to establish something, okay, get it like this, put it down like this. Okay, now what we should be doing is this 75. Remember that when we are comparing it, okay, this ratio will be having some values in between it. Okay, let's say that this is milk in liters, this is water in liters, and so this will be milk in liters and this will be water in liters. So now when you try to mix them, you should mix milk with milk and water with water, never milk with water and water with milk. Okay, that means that you should not employ this value, you should not multiply with this value with this or this, but you should be multiplying this with this or dividing this with this. Okay, division only I'm saying. So now let me tell you why I said it. Okay, see this, when I write it in fraction 75/87 and 25/29, I can write it like this, right? 75/25 and 87/29. Can I? Can I write like this? Skanda? Can I write like this?
Yes, ma'am.
Yes, I've just changed the places. So now see, now this will be easier for you to divide, right? 75 and 25 are 5 multiples. It is very evident over here, right? Okay. Now try this out. $25 and 75. Just the simplification you're going to do. Simplification means on the numerator also you should be having some value, on the denominator also you should be having some value. It can be of 1 now also. If you're completely dividing it, you write 1 over there. Skanda, give me the value for left side, and Shivani, give me for right side.
I was doing right side.
You're doing right side. Okay, then give the value of right side alone. Skanda, you have to give me left side value.
It's all right.
Okay, wait a minute. Oh no, wait for a minute. Let Skanda also do. Yeah, 75 by 25. What could be the value after 75 by 25? Yes, Skanda. Yeah, what happened? 75 by 25, what the value? 25 two times is what?
And 25, ma'am?
Two times. 2 times 25 is what?
Into 2, ma'am.
Yeah, 25 into 2 is what?
Um, 50, ma'am.
Okay. Now 50 plus 25 is what?
50 plus 25, ma'am.
Yeah.
75, ma'am.
Now 25 into how much you should put to get 75?
3.
Yeah, 3. Okay. So 3. 3 is the value. So it is nothing but 3:1. So what is this value, Shivani?
Ma'am, I did it with 29 itself, ma'am. 20 by 1 by 29 by 1.
29 by 1. Check it. 29 by 1.
Ma'am, I actually divided the top part with 3, ma'am.
3. So if you did it with 3 means this also will take some other value, right? How can it come as 1? It can't come
Ma'am,
as 1.
down part I got confused and I did it like that itself. That's what happened.
Okay.
And that also I did 3, ma'am.
That also?
3, I think, ma'am.
That also 3 by 1 only. Okay. Both are 3 by 1, 3 by 1 only. Okay. So see this now. If I again rearrange this, because what is our ratios now? Our ratios are different, right? Okay. Our ratios are 3 by, this is 75 divided by this, what we need, divided by 87. So 87 is also 3 is equal to 1 by 1, right? So this is equal right now. I can
Yes, ma'am.
cancel this and I can get it 1. So 1 by 1 is to 1 by 1. So now it's going to be equal only. So 75, 87, okay. It is nothing but 25. If you 25 is to 39, 29, if you multiply them both with 3, you are getting this value, right? So it is nothing but your 25 and 29 multiplied by 3 and 3. Multiply and divided by 3 and 3. You will get this. So these values are equivalent. So we won't be telling it as equal values, but we tell it as equivalent value. Equal values means this is equal value. Okay. But this is equivalent value. Okay. Because there is a change in the number, but they can be reduced to this form. Okay. So we tell it as equivalent and this as equal. Okay. So now this is how you will be finding the equivalency of two ratios. Okay. Just by putting them in fractions, you will verify for any kind of same number can be divisible or multiplied so that I can arrive with the next number or not. That you're going to check. Okay, now see this problem. Are the ratios 2:5 and 4:7 equivalent? This is the question.
That we can't check. We we should be checking like crisscross and check now, ma'am.
Yeah, that we should be checking in
Because like it won't go 5 table, there is no 2 or 2 table, no 5, ma'am.
yeah. So what
So,
we'll be doing is,
ma'am, how will check 5 by 7, ma'am?
we'll see now whether they are equivalent or not. Okay. So now, how to check the equivalency in other terms? Okay.
Ma'am,
But
we have to crisscross and multiply, ma'am.
no, you won't be crisscrossing and multiplying. Okay, right. So wait, what we'll be doing here is okay. See, what we are doing here is we are reducing them into decimals. Okay. So one way is see this. Okay. One way, remember this. If we try to reduce them in decimals, then we'll be getting the exact values, right? Because that's going to be one single value. If that is going to be equal for both of them means then they are equivalent ratios. Can you understand this? See, if we reduce them to the ratio value, decimal values, even this value 75 and 87, if I reduce them, okay, if I reduce them, I'll be getting some value. And this 25 by 29, if I reduce them or reduce them to the decimal form, I'll be getting some value. And those value will be equal. So how you'll be doing that? That nothing but 75 divided by 87 you'll be doing. Okay. Then only you can find that whether they are equal or not. Okay. Or we can employ some other method also. Okay. Alternate method. So this problem. Okay. So what we can employ over here is, okay, right. So what we can do in other words is, okay, we go to the screen and tell you, okay. So one way is what? One way is decimal formation. Decimal formation is one way, okay. Another alternate method is, okay, common denominator. Common denominator method, okay. So decimal formation is simply put, okay, how you'll be forming the decimal formation. If I write 3 by 4, okay, you will be writing 3 divided by 4, okay. So now this is 3, so you'll be putting a point over here, a 0 over here. So 4 will be coming as 28 in 7 times, then 2 balance, then again a 0, then 4 will be coming as 5 times, so then 0. So now what it is? 0.75 is the value. Okay. See, this is a number, one number. And if I write 6 by 8, okay. If I again do this in this division formation, that is 6 divided by 8, okay. So what I'll be doing? 60 I'll be putting. I'll be putting a point over here, 0 point, 0 point. See, 0 point. And 8 in tables of 60, it will be coming as 8 sevens are 56, right? Then I'll be getting 4 balance, then putting a 0. 8 fives are 40 and 0. See this decimal forms, this also gives me 0.75 and this also gives me 0.75. So now what happened? These both are become equal. So this is a method of finding the equivalence.
And these two ratios are the examples of that Skandas and his brother says.
The 3 by 4, yeah.
3 by 4, 6 by 8.
6 by 8 also were there.
Yes, ma'am.
Okay, right. Skanda, can you understand
When
this?
we simplified that only, we got 3 by 4, ma'am.
Okay, right. Right. Skanda, did you get this? How we are checking?
Yes, ma'am.
Yeah?
Yes, ma'am.
Okay. Right. Okay. Okay. This common denominator method, we'll try to do it in the next class. Okay, now the time is up. Okay, we'll see this common denominator method in next class. You can take this one into your notebook. Okay, for equivalency. Equivalent ratio. Skanda, you can take a screenshot.
Yes, ma'am.
Completed. Okay, right, students. If completed, you can leave the session. Okay, we'll see in the next class.
Thank you, ma'am. Have a great day.
Thank you. Have a great day. Skanda, you also completed?
Yes, ma'am.
Okay, right.
Yes, ma'am. Thank you, ma'am.
Thank you.